Encrypting data in transit. Oracle calls it Native Network Encryption. Native Network Encryption. This encrypts the SQLnet traffic, the client-server traffic between the user process that generates the SQL, the server process that executes the SQL. And we need to encrypt the traffic in both directions. Until quite recently, Native Network Encryption required licensing the advanced security option. And this was a pretty appalling situation. Firstly, because advanced security option costs money, but much worse for many sites is that it was an option on top of Enterprise Edition. And I think, like many people, I always felt that this was absurd. What it meant was that for those of us running on standard edition licenses, network encryption simply wasn't possible at all. It just wasn't possible, full stop. However, from release 12, Native Network Encryption is now bundled. I don't like to say things are free, but now bundled or included in all editions. So even if you're running on Oracle XE, the free edition, you still have access to Native Network Encryption. So XE, SE2, Enterprise Edition, network encryption is now always available free of charge. It's also available in all releases. The license change occurred in release 12, but the license change has been backported to earlier releases. So for those of you still using version 11, for instance, if you look at your licensing guide, you will see that network encryption is a license extra on top of Enterprise. It isn't anymore. It's delicensed, backported to all editions, all releases, and that's long overdue. Now, the encryption is enabled declaratively. It's just settings in the server-side SQLnet.ora file. Okay, it can also be configured with settings on the client-side SQLnet.ora file. But since, if I remember correctly, release 12, you now need to configure it only on the server side. The server-side configuration is enough, and all clients will then accept what the server has requested and encrypt if the server is configured appropriately. In earlier releases, it was possible to override the encryption on the client side. Anyone would want to, and in some circumstances you would have to configure the client as well. But from release 10 onwards, server side is all we need to consider.
John, is there a performance hit by enabling this encryption?
I don't think so. I've never actually been able to measure it, which means nothing more than that I haven't been able to measure it. However, the way I look at it is that even if there were a performance hit, as a DBA, it simply isn't an option for me. I can't go to my users and say, I'm not encrypting because of a performance problem. If the rule is they have to encrypt, as a DBA, I have to do it. However, my own opinion is that there really isn't any performance overhead. I believe that most modern hardware encryption algorithms are burnt onto the firmware, so it isn't being done consuming CPU cycles in the way that perhaps it did in earlier years. So I wouldn't bother about the performance hits. You've got no choice, and I personally don't think there is one. Now, native network encryption on the client side, ideally, you don't have to do anything at all. If it's an OCI client, Oracle Call Interface, something written in C, and that might be SQL+, forms, anything written that's got the Oracle client into the OCI, the Oracle Call Interface libraries included, there's nothing to do at all. The client will do the encryption when it sends data to the server, decrypts and receives data from the server with no configuration whatsoever. It's all happening well below the level of the software. The same thing applies to JDBC thick clients. With the JDBC thick client, you link in the equivalent of the OCI, it's the equivalent of linking in the OCI libraries. You enable all the classes that let your Java clients talk OCI. In those as well, nothing to do on the client side whatsoever. JDBC thin clients, yes, there is a certain amount of encryption, but it's still declarative. There isn't any programming actually needed. And I did look up the docs just now. And as an example, this, by the way, where I am here is configuring thin JDBC client network. And if we work our way down, data encryption, and they give some nice examples of how to do it. And there's a bit of code given here. So JDBC thin client, it's pretty straightforward. Import java.sql as you would normally, import Java user properties, import or get your JDBC libraries loaded. So that's your JDBC thin client coming in. And there we see the extra import, where you need to import the ANO as advanced networking option. You import the ANO classes that Oracle supplies. And then your thin clients will be able to do the encryption as well. You have to set a couple of properties. Here we see an example. There's building our connect string. And then the properties we set coming in there. So pretty straightforward. Oh, checksumming as well. I'm not going to talk about checksumming today, but just as we can do encryption declaratively, we can also do checksumming and integrity checks as well. So small amount of configuration required on the client if you're using JDBC thin, which I'm sure many of you are.
John, question in the queue. Do we have to enable NNE if using ORDS 19.2 and Apex 20.1 running on database 12.1 on Exadata? The table spaces are encrypted, but do we need to enable NNE?
I think you do. You must definitely need to enable native network encryption. ORDS, remember, is an Oracle user process like any other. And when it's establishing its connection pool to your Apex database, it's using SQLnet. You should definitely be enabling encryption there. Now, ORDS is, of course, Oracle aware. So you don't have the thin client problem. It's an Oracle aware product, which is provided by Oracle. So the same thing we're going to look at right now, you would also configure in an Apex environment, and then all your Apex client server traffic will be encrypted as well. Of course, with Apex, you're going to take it further. You'll be using SSL encryption, HTTPS, for the traffic from the middle tier to the browser, but that's out of scope for today. So to round this up then, what I'm talking about right now will work with any Oracle client, including ORDS.
John, what algorithms are available?
More algorithms than you could shake a stick at. You've got AES, the Advanced Encryption Standard, 128-bit, 192-bit, 1256-bit. 128 is the default. To my mind, AES 128 should be enough for anyone, but some sites do demand 256-bit. Oracle Native Encryption can do that. It will also use the cipher block chaining to make it even more unbreakable. And if you have particular requirements, probably government requirements, it can do those specialized algorithms. There's what do they call it? The ARIA, ARIA, the Academia Research Institute. It can also do that Korean Information Security Agency one. And it can also do the American Data Encryption Standard, the triple DES standard with 112 or 168 keys, again with cipher block chaining. So for most sites, I would think the AES is going to be fine. The default of 128 may well be fine. But if you have particular requirements, they should be there as well. Now, so how does this actually work? And I'll configure it and demonstrate it as we go through this at this point as well. The native network encryption is symmetric key encryption. So we're not talking secure sockets. We're not talking public-private key. And that's, you can configure public-private key encryption if you really want to. You can do that, digital certificates and everything. The native network encryption doesn't use that. That, I believe, is a design decision, and it's a design decision that I completely approve of. Symmetric key encryption algorithms are, generally speaking, a lot faster than public-private key mechanisms. They're generally faster, they're certainly easier to administer. And for this level of traffic, where we're talking client-server communication, you're using a known client talking to a known server, probably on the same local area network segment. Symmetric key encryption is not only faster, it's going to be perfectly adequate. Now, I see, if you really wish to, you can configure secure sockets for the client-server connection, but that's a separate process, not part of native network encryption, a lot more work, and in my opinion, not really needed. When would you need it? If you don't know who your clients are. Well, we do when we're talking at this client-server level. So it's symmetric key encryption using the algorithms that I mentioned earlier. Keys are generated for each session. So every log onto the database gets its own key. There was that mention of Apex. So in that case, when you establish your connection pool, each connection in that pool will be encrypted with a different key. And when the pooled connections expire and new ones are created by ORDs, a fresh key will be used for that new connection. The key transmission between client and server is using the old Dillie Hellman algorithm, as I think do most things. Dillie Hellman algorithm with a few modifications.
John, hasn't Dillie Hellman been broken?
I think some people claim to have done it, but if I remember correctly, it was all one big fiddle. The same key was used for a long time. They were given information about the length of the key and the limits within which it was being used. And they did manage eventually, some group did manage eventually to crack it, but that was nothing like the real world. And when you add in what Oracle calls the authentication fold-in, their own modification to Dillie Hellman, that should be even better. It uses user identities as part of the fold-in to make the transmission even stronger. Combining that with the fact that fresh keys are used for each session, I think we can assume that Oracle's native network encryption, the key transmission, it would take a supercomputer till the end of the next century to crack it.
Right, thank you.
So when the client and the servers talk together, they negotiate to choose an algorithm. An algorithm can be specified on the server side or on the client side, but if no algorithm is specified, they choose the strongest available between the two. You can also use integrity checks, MD5 or SHA1. Checksums can be included in the datagrams as well. It's a very similar technique, needs configuration only on the server side. I'm not going to demonstrate that today. We'll stay just with the encryption. So let's try it. Because it's vitally important, not only that we can do it, but we can demonstrate that we can do it. I'm working just on my Windows PC here. Now, to configure it, I'm going to configure it purely on the server side, because from release 10, that's what we can do. And in your network admin directory, we've got our old friend, SQLnet.ora. Let me just push the font up on that. I'm going to first off demonstrate how easy it is to intercept SQLnet traffic, how easy it is. So at the moment, I shall enable tracing. I don't have a network sniffer running within my PC, but enabling Oracle SQLnet tracing will show us the datagrams going to and fro between SQLnet. And so we will actually be able to see the traffic in progress. And that's what anyone would see if they tapped into a network segment containing SQLnet traffic. So I'll enable tracing. Trace files going to ctemp. And let's see what happens when we actually log on. So I'll just make sure my listener is running okay. Yes, it is. SQL plus Scott Tiger at and just run a simple query. Select star from dept. So that goes to the server. Back comes the result set. And let's see what's actually happened in terms of the trace. So my trace directory should have gone to /tmp. Oops. Oh. Right. No trace file come out yet. Oh, I didn't save that, did I? Helps you save your file. Let's do it again. And there's my trace file. Take a look at him. So just stepping through the trace file, let's see if you can actually find the traffic. Edit, find. It is a bit hard to identify exactly what we're going to look for because of the various format. Oh, here we are. These are the datagrams that went between SQL Plus and the server. There's the statement I wrote, select star from dept. So that's the traffic from client to server. And a couple of datagrams later, there are the column headings, dept no, dname, the lock column that we saw there. And then the actual row data, accounting, New York, there it is. So it's that easy to intercept traffic on the network. Any network sniffing tool can do it. We're not seeing the numbers. Now the numbers are there. Department 10 will be encrypted in these hex codes here. Varchar 2s are very easy to see. Dates and numbers, Oracle has published the encoding mechanism, so it's all there. So that's how easy it is to intercept traffic on the wire. So what do we do about it? Right. Edit in SQL.NET.ora. All I need to do is add one directive. SQLnet.encryption server equals required. So in your server-side SQL.NET.ora file, just add that. That means that the server is going to demand encryption. If it hits the client will say, ooh, I better encrypt. Because from release 10 onwards, the default is to accept encryption if it's requested. And that was an important change in release 10. You need to only configure it on the one side. I haven't specified an algorithm, though one certainly could, so they'll negotiate and choose one for themselves. So I'll save that, save, and then we can try it again. If I log on, run the same query, and exit, I should now have got another trace file, which should be that one. And if you look at that, oops, and search for CHI for Chicago. Oops, can't do it like that. Edit, find Try to find Chicago. Nothing. It's that straightforward. It is that simple. All you will see here are the datagrams. And all you see in the datagrams is a load of junk. So couldn't be simpler. And that is native network encryption.
And no requirement to enable on the client side, John, nor can they turn it off?
They cannot turn it off. What they could do is in the client-side SQLnet.ora, you could configure that directive on the client side. You could specify SQLnet encryption client equals rejected. And that would mean the client would refuse to encrypt and it simply wouldn't be able to log on. But there's no way the client can override this setting on the server. So that was native network encryption. One setting in SQLnet.ora. And now a commercial break.
Yeah, literally 30 seconds of your time. I just want to remind you guys what SkillBuilders does. I mentioned before, we do cloud hosting for Oracle Database and Oracle Apex apps, remote DBA, sometimes some on-site DBA as well. Of course, with the situation in the world today, it's all remote. And Apex application and design and development. We'd like you to keep us in mind. And one other thing that you may know us for is training. And we've got an encryption class coming up. So John, could you take that URL and post it into the chat? That would be really great. So John's going to be teaching a class coming up soon here on encryption. So if you're interested in a full class on this, it's coming up. Thanks, John.
And we cover a lot more than encryption on this, by the way, including some very sophisticated capabilities that we can now do with PL/SQL or code-based access control. But it's an enjoyable class. It's an enjoyable class, particularly when we talk about having fun with SQL injection.